Hey seniors, today we're going to continue with two representations of data in terms of comparing constant rate and initial value. So let's go ahead and jump in. On your notes page, go ahead and draw your line. In the top left-hand corner, go ahead and write two representations of data. Don't worry about this yet. I'm going to tell you what to write. Before we jump in though, I want to go ahead and review. When I say rate of change, you all should immediately be saying, Miss Abel, you're talking about the slope of a line. And when I say initial value, that of course means my y-intercept or my starting point. You don't need to write that down. We did that all last week, but make sure that we remember those two descriptions. So let's go ahead and talk. A linear relationship is a comparison of two things that increase at the exact same rate every single time. So for every time that x increases by 1, y needs to increase by the exact same amount. Data is often represented in different ways, which we have seen already through tables, equations, graphs, etc. Today is all about identifying correct statements about slope, which is the same thing as rate of change, and the y-intercept or the initial value. So basically what we're going to be doing today is looking at graphs, tables, equations, and trying to figure out statements that are true about them. All right, so let's go ahead and jump in. You don't have to write this. I'm going to tell you what to write. All right, two brothers had a friendly rivalry. As they grew up, they competed to see who could be the tallest. Boy, I know I did that with my sister, and she is still peeved that I turned out to be taller. When they started the bet, Marky was 65 inches tall and grew 2.5 inches per year. His growth equation was y equals 2.5x plus 65. I want you to write that on your paper. My pen is your pen. 2.5x plus 65 equals Marky's growth. I want you to write that on your paper so you have something to compare to. His growth equation was 2.5x plus 65, where x is the number of years they have had the bet and y is the respective height. The older brother, Ronald, has his height displayed in the table below. And on one side we have year and one side we have height. Go ahead and draw this table in your notes page so we have something to compare to. Now, I can't really compare anything until I get these in the same form. So since I already have an equation for Marky, I'm going to go ahead and write an equation for Ronald's height growth. And the way that we do that is we find the slope of the table and the y-intercept. So again, of course, slope is change in y over change in x, where x is my number of years, y is my height value. So change in y. I'm just going to pick my first two values. So I'm going to have 64 minus 62 over change in my x values, which is just 1 minus 0. 64 minus 62 is going to leave me with 2, and then 2 minus 0 is going to leave me with 1. So I know that this table has a slope of 2, and then of course I add my x value. My next step is to add my y-intercept. Now, this is a part where a lot of you guys keep getting confused. Wherever x equals 0 on my table, which is right here, y is my y-intercept. So, if x is 0, y is 62. So my growth equation for Ronald is y equals 2x plus 62. Now I can start looking at my answer choices to figure out which one of these is correct. So I'm going to go ahead and read the first one to you. Which of the following is true? A, they have the same starting heights, but their rates of growth are different. Okay, I'm going to go ahead and underline they have the same starting height. That can't be true because if it's the same starting height, that is my starting point for both of my equations. And both of my equations, the starting point or the y-intercept or initial value is 65 and 62. Those numbers are different. So I know that answer choice A can't be correct. So I'm going to go ahead and mark through it. B, they had the same rates of growth, although Marky started out as 3 inches taller. If they have the same rate of growth, that means that their rate of change is the same, which means that they would have the same slope, which also isn't true because Ronald has a growth of 2 inches and Marky has a growth of 2.5 inches. Let me go ahead and write Marky's equation so we don't get confused. So I know that answer choice B cannot be correct, so I'm going to mark through that. And this is literally what you have to do, is go through and each answer choice and figure out, is this true or false? All right, C. Ronald grows 0.5 more inches than Marky per year. That would mean that he would have a larger slope. And that also cannot be true because Ronald grows 2 inches per year, while Marky is growing at a rate of 2.5 inches per year, per my slope. So I know that answer choice C cannot be correct. That leaves me with D. Marky grows 0.5 more inches than Ronald per year. That statement is true because 2.5 is 0.5 more than 2. So answer choice D is going to be my final answer. And that's literally what we're doing today, is creating equations and figuring out, is this true or false? Let's do another one. All right. Wilma created a table below to show the relationship between the amount of time in hours spent walking dogs and the amount of money she earns. So go ahead and draw a rough table where X is my hours walking dogs and Y is my money earned. Now I'm comparing this table to this other equation of M equals 3T plus 12. And this is my equation I'm comparing the table to. Before I can compare these, I need to write an equation for my table. So again, change in Y over change in X. So I'm going to have 28 minus 16, again, just taking my two values here, over 4 minus 2. 28 minus 16 is going to leave me with 12, and 4 minus 2 is going to leave me with 2. 12 divided by 2 is going to leave me with 6. So I know the table is going to have a slope of 6. Now I just need to figure out my y-intercept. I'm going to look at my table and I see that it doesn't show me where x is 0. So I need to figure that out for myself. The way to do that is just to create your own table. So if I'm at 2, my y value is 16. If I have a slope of 6, that means that this is increasing by 6 every time. So when x is 3, y is going to be 22. And where x is 4, y is going to be 28. So then I can go backwards. If at 2, y is 16, if I'm going backwards, at 1, y is going to be 10. And then if I go back to 0, where x is 0, if I'm going backwards by 6, y will be 4. So my equation for my table will be y. Go ahead and erase this so we can see clearly. It's going to be y equals 6x plus 4. Now that I have my two equations, I can start comparing them. All right, so which statement is true about the two linear relationships? All right, the first one. A, the table has a steeper slope of 12 than the slope of the equation, which is 3. Well, that can't be true because our slope of the table is actually 6. So I can go ahead and mark through answer choice A. B, the relationships have the same starting point at 12. Well, that also can't be true because the starting point for the equation, the first equation, is 12, but the starting point for the table is actually 4. So we can go ahead and cross through that as well. C, the table has a higher starting point of 16 than the starting point of the equation, which is 12. Well, again, our starting point is 4, not 12, or sorry, not 16, so we can go ahead and eliminate answer choice C. That leaves us with answer choice D. The table has a steeper slope of 6 than the slope of the equation, which is 3. That is a true statement because 6 was the slope of our table, and 3 was the slope of the equation. So answer choice D would be my answer. And again, you see how I used process of elimination? I went through each answer choice and said, yes, that's true, or no, that's false. So that's all we have to do. All right, guys, that's going to be it for me. Let's go ahead and practice.